Hi, welcome to AB Video 7.2a Part 2, more on volumes by revolution, etc., etc. Set up and evaluate the integral that gives the volume of the solid formed by revolving the region about the y-axis this time, okay? So the region is y is bordered by y equals the square root of 16 minus x squared, the x-axis and the y-axis. So again, it can't be the whole thing because then it wouldn't be bordered by the x and y-axis. So it has to be either the right side or the left side. So I'll take the right side. So again, if you were to square both sides, being the x, you'd realize it's a circle, center, origin, radius 4, but it's y equals a positive square root, so you only keep the top half. We are rotating on the y-axis this time, so it's the first time we're doing this. Therefore, your little rectangular strips have to be horizontal because they have to be perpendicular to the axis of rotation. So now what happens when you rotate this little rectangle about the y-axis, you're going to get a disc, only it's going to be oriented the other way. Now, now the height of our disk is dy because it's vertical, and now the radius of our disk is actually the x coordinate. So we are rotating on the y-axis, which is one of the borders, so we will get a disk, pi integral r squared h. The h, as we said, was dy. This is the square of the radius. The radius we had agreed was x, but we got to change x in terms of y. So you would have to actually isolate the x and realize that if x squared is 16 minus, oh, right here you have x squared is 16 minus y squared, and that's what you have is x squared, and x squared is 16 minus y squared. Now, be careful because it's dy, this has to go from y equals to y equals, which is the bottom border, which is y equals 0, to the top border, y equals 4. Next one is the region bounded by x equals negative y squared plus 4y, y equals 1 in the y-axis. So it's a little tricky. If you factor out the negative y out of this, you'll get negative y times y minus 4. And if you decide you want to find the y-intercept, you would replace x by 0. Well, you find out that x is 0 when y is 0 and y is 4. So the graph, it's a parabola. You should know it's a parabola opening up sideways and it opens up to the left. And you now know that it cuts the y-axis at 0, 4, and 0, 0. The other border of this region is the horizontal line y equals 1, and the third border is the actual y-axis. So this is the region they're talking about that's bordered by all three things. Now, they want to revolve about, all these questions are revolved about, the regions are revolved about the y-axis. So I'm going to take my little strip to be horizontal, which is perpendicular to my vertical y-axis, axis of rotation. And so when I take that little rectangular strip and rotate it, I will get the following. I am rotating on an edge of the region, so again, it'll be a disk. H this time is dy. My radius would be the x coordinate of that point. But of course, because this is dy, everything has to be in terms of y, so I will have to replace that radius, which is x, by what x is equal to in terms of y, which is negative y squared plus 4y. Again, because it's in terms of y, we're going to go from the bottom border, which is y equals 1, to the top border, which is y equals 4. And then you'll square that and be on your way. Okay, volumes by washers. I'm just going to introduce them. We'll do them in the next video. So now you have the region bordered by the parabola y equals x squared, x-axis, etc. But this time we're rotating on y equals negative 2. Now, y equals negative 2 is not one of the borders. Hence, we will not get a disk. So let me show you that on Calculus in Motion. Okay, reset. Okay. Why isn't it letting me do this? We don't know why. Okay, we'll close it and we shall reopen it. Let me pause. Okay, so I'm taking this back again, but this time I'm going to leave the axis of revolution down here. So the axis of revolution right here is y equals negative 2 as opposed to the x-axis. So you can really easily see that the axis of revolution is not one of the borders. So that when I take this little rectangular strip, there'll be a space inside, right? Okay, so that what happens is you don't get what's called a disk, a solid disc, you get what's called a washer, which is basically a disc with a hole in it, okay? Now, obviously, the formula is not pi r squared h because it's not a single cylinder. It's actually a big cylinder with a cylindrical hole in the middle. So it's going to be different. Okay, so here's what we have. So here's our y equals x squared, x-axis, x equals 2, x equals 5. So here's our shaded region. We're rotating along a horizontal line, y equals -2. So that's horizontal, which means our little rectangular strips have to be vertical. And therefore, now when you rotate, now watch how I do this, okay? Because people have a hard time creating this drawing. My little rectangular strip starts here on the x-axis and goes up to about this height right here. Then there's the space between the bottom of the strip and the axis of rotation, which is here. Whatever length you have between here and here, reproduce it between here and here. So that gives this guy. Whatever length you had between these two little horizontal strips, you're going to make that the same length as over here. So now you get to see that we have what's known as a washer. Well, the formula for a washer is the volume of the outer cylinder minus the volume of the inner cylindrical hole. So I'm going to call the outer cylinder's radius capital R, and I'm obviously at school at 3:05. It's very noisy now. And I'm going to call the radius of the small one. So here's the radius of the big cylinder, and here's the radius of the small cylinder, always measured from the center, which is where the axis of rotation is. Now, you can pull out the common y, you can pull out the common h, they have the same height, but what you are going to be doing is subtracting big R squared minus little r squared. Thank you. You're welcome. Now, I want to point out, and this is crucial, that big R squared minus little r squared is not the same as big R minus little r all squared. And people are going to do that. They think it's the same thing. It is not the same thing. Now, you're really going to need a good picture because you now have to figure out what is, okay, first of all, the height is horizontal, so it's dx. Okay, so you'll need a good drawing. The little radius is the distance between the x-axis and this line y equals -2. So hence the little radius is just 2. It's a length, right? But the big radius is adding to this height here of 2 plus this height here. Well, that's the point xy, so this height here is y plus 2, and that's my big radius. So it's y plus 2 squared minus 2 squared. It's dx, so this goes from left border to right border, which is x equals 2 to x equals 5. Don't forget the pi. But we can't leave this in terms of y because everything has to be in terms of x. So you go back to the fact that they told you y was x squared. So you replace y by x squared, and then you're on your way. Here's another quick one. Region bounded by the graph of y equals 2, which is this red horizontal line. And here's this parabola, y equals -x squared over 4 plus 4. We're revolving on the x-axis. So you can tell the x-axis is not one of the borders of the region. We are going to need the points of intersection, so we do need to solve the system. Y is equal to 2, y is equal to 4 minus x squared over 4. That'll give you that they intersect at 2 root 2 and -2 root 2. Now, the axis of rotation is horizontal, so I've got to draw a little rectangular strip that's vertical, and it's got to go from the top of one curve and then to the other curve. When I rotate that guy, because there's a space, I'm going to end up. So here's your axis of rotation. So again, my little tick marks. Here's the axis of rotation. Here's where the bottom of the rectangular strip is. Here's where the top is. Whatever that length is, reproduce it here. And whatever that length is between these two, reproduce it down there. So it is a washer. It's pi big R squared minus little r squared h. My h is horizontal, which is dx. So it goes from left border to right border, which is those points of intersection we found. Big radius. The big radius goes from the axis of rotation all the way to that top point. Well, that point is the point xy, so that is y. The little radius is the distance between the x-axis and the line y equals 2, which is just 2, but you can't leave this in terms of y. You will have to replace y by 4 minus x squared over 4, and you're fine. Now, because it's symmetric, you instead of going pi from -pi 2 root 2 to 2 root 2, you could do 2 pi and then do 0 to 2 root 2, and that